Then when you want to then test your data, right? They call it the validation point. So that validation point, you're trying to validate, oh, if you were to deploy this particular model into the real world and it receives new data, will it perform better? Will it make better accuracy? Will it make better prediction, forecasting, and whatnot? So during that validation period, you are actually giving your model some set of new data it had never seen before, right? So if you had compared properly, you'd see that the predictions it made with the training data, if you were to calculate the mean absolute error of that, you see you'll be having a very high value or a very high percentage, maybe from 90% almost 100, right? Because it's training data. What you're just telling the machine at that time is that, oh, I'm giving you some data to train from, and I'm still giving that same data to evaluate, right? It would always give you a very high figure. But when you give it new data that it hasn't seen before at all, it will then use its ability that has learned from and to evaluate. So I hope you understand all of this concept and this particular cycle before we move to the next um, concept, basically. Or do you have any doubts as to your implementation? Kindly bring them on and we'll discuss about it. All right. So yeah, today we are supposed to talk about, I think, classification and clustering model. So yeah, so classification and clustering models actually, just like I explained in one of our first contact session, is that these are models that are unsupervised. So when we talk about unsupervised machine learning model, what we are saying basically is that it's a situation where we are feeding in our machine learning models with data that are labeled, right? So just like I explained as well, unlabeled data, these are data that don't have any inscriptions to them. So for example, in a real world use case, right? If you want to make a supervised machine learning model on a meal, for example, so we said if you have a meal, for example, right? So you give your machine some set of ingredients. You also give your machine some set of instructions to prepare that meal, right? And at the end of the day, you'd also give your machine a sample of the meal that you're going to make. But let's make use of the house pricing data as an example. So for the house pricing data, we had different features, right? We had number of rooms, units, location, um, geolatitude, geolongitude. We had, um, several features, right? If, I can't remember them all at this moment, but some of those features actually determines, a particular house, right? So if you have noticed, some houses with 3 bedroom, you know, would have higher prices than houses with, say, for example, a 1 bedroom, right? Houses with geolocations that are further than, some axis is always higher than the other. So what you're saying basically is that you're saying, oh, machine, take these particular features of this particular house, right? Understand them and learn from them. Then also take the prices of the house, right? You are giving it plus the prices of the house. So that when you feed it with new data, it will then know that, oh, this new data that I'm getting, let me inspect the features in this particular new data. And once it inspects the features in this particular data, it then decide that, oh, from history or from what I've learned so far, I can then conclude that houses of these similar features would cost this particular amount at this point in time. So that's supervised learning, right? But unsupervised learning is the opposite, right? If you notice, the formula is you're giving the machine some input and you're also giving them output, right? Desired output so that it can learn from. While in unsupervised machine learning, what you're doing is that you're giving it input and you're not giving them output. So you're telling the machine, oh, decide for yourself how to figure this out. So one of the best real world case I would give an example of is, say for example, you have a blog, right? You have a blog, you own a blog, and you have different blog posts on your blog, right? So these are data, right? You have data of individuals that actually visit your blog post every now and then, right? But you wouldn't be able to determine a lot of things from these individuals, right? You cannot tell if this certain amount of people are visiting your blog at night, or if this certain amount of people are actually visiting your blog during the day, or you cannot even decide if this certain amount of people reading my blog are of the age range of maybe say 30 to 50, or of the age range of maybe 70 to 100, for example. All of this cannot be determined, right? It's unlike the house pricing data where we already know the prices of some houses. But in this case, we don't know, these things. So what do we do basically? Do we feed the machine with inputs and not outputs, or do we feed them with both input and output? So in unsupervised learning, we don't feed them with output because we are not so certain on what the output is. What we are saying is that, oh, take this set of inputs, learn from them, and put them into clusters, right? So what it does basically is that once the machine comes onto your blog post, it actually inspects the number of people that visit your blog posts. So it places them into clusters, right? It learns from their activities, within your blog post and how often they interact with your blog post and all of those processes, right? And it's then able to group that, oh, this certain amount of people visit my blog posts at night, or this certain amount of people within the age range of 30 to 70, for example, reads more content relating to health, read more content relating to finance and all of those. So the machine is able to group all of these things in clusters, right? A good example as well that we all know of is recommendation systems, right? Recommendation systems, just like YouTube, for example, just like I explained in previous contact session, is when I watch sports most of the time, and for example, you watch entertainment content most of the time. The clustering model actually groups us, into different clusters. So it groups me and several other people that watches sports into a particular group, and it actually groups you that watch entertainment content with several other people that watches entertainment content into, or content rather, into a particular group. And it says that, oh, okay, I have a list of people that watches sports, let me recommend more sport content to them, right? I also have people that watches entertainment content. Let me recommend more entertainment content to them. And if you notice as well, if you had a period of time where you switched from watching entertainment to maybe something else, you'd also notice that YouTube is now suggesting or recommending videos with your new desire, right? You probably just desire to start watching football, for example. It automatically removes you from the entertainment cluster and puts you onto the sport clusters, right? So you then start receiving recommendation about sports. So this is how unsupervised learning works, right? And the two most common models within unsupervised learning is clustering and classification, right? Clustering and classification models, basically. So that's basically what we're supposed to discuss today. There are not so much to do within clustering and classification. All you just need to do is just to follow the same implementation you had while you were making use of decision tree and random forest to implement this, right? But it's just that the algorithm is going to be different, right? So the different kind of algorithm that we use, basically sometimes logistic regression and sometimes support vector machine. So I'll be sending to you guys resources on how to get started with classification and clustering model. and you'll be able to make use of the support vector machine algorithm and the logistic regression algorithm to perform classification problems and clustering problems, basically.
Okay, sir.
So, yeah. So basically, that's what we do for classification and that. So for the assignment, I think I don't have access to the assignment now. Do you have it on the LMS platform?
Uh, I'm not logged in on the LMS platform now. I'm coming.
Okay. All right.
It might take a while though, because I'm listening to this lecture on my tab and my laptop is on sleep mode. Shoot.
Oh, all right.
Ah. But I was able to access the platform. I I think I submitted my assignment around 2:30 today. So I was able to still access the platform today. Hello? Hello?
All right. Oh, okay. So that's not a problem at all. Just what we'll do is that I think I can remember that correctly. What they want you to do is to make use of a particular data set, right, and perform clustering algorithm on that data set, right? And the other one is classification. So classification, what they want you to do with classification is to train a model that will be able to detect spam or harm emails, right? Can you remember the explanation I made on classification models earlier in this cycle, where I discussed about spam filters and how you can train a model to be able to understand if a mail is coming in as a spam email or a normal email. Did you get that, Yemisi?
Yes, sir.
All right. So that's basically what they want you to do, right? So the data set you're going to be having is a data set that has information about spam and ham emails, right? So this spam and ham emails, you are just going to be making use of this particular data set, right? And you perform classification models on them, right? So figure out two things, right? One, um, the algorithm, the best algorithm to use for classification problems, right? Perform this particular model on these data sets and classify between ham and spam emails, right? Then the third one would also give you another set of data that you perform clustering on. So this particular data would give you is would be unstructured and we don't have any sort of output to them and they will be unlabeled, right? Just like I explained. And you figure out which of the algorithms is best used for clustering problems, right? Then you use that clustering algorithms to solve that particular problem with using the data sets. So that's basically the two assignments that we have there. For the next concert section, that's I think the third for today, right?
Yes.
We were supposed to talk about some of the real world use cases of data science, and which we've actually made mention of a couple of them during the course of this cycle already, right? So what we'll be doing in our next contact session, we'll be discussing about two things, right? One will be natural language processing, and the other one would be um, pipelines, right? Creating machine learning pipelines and saving your pipelines for the use of APIs. So that would be our last topic for this particular cycle. Then we could go on and do a few revisions, get yourself acquainted with some of the models, do more practice, engage with more data on Kaggle platform, and we are good to go.
Okay.
All right. So I think we are good for today. When I get access to my laptop, I'll send you the assignment and some of the data sets you have to make use of, basically.
Okay. Thank you, sir.
Then I'll also send you resources on how to get started with clustering and classification. Right.
Okay.
All right. So do you have any questions?
No.
Okay. So I think that should be sufficient for today's contact session, basically. Um, Apologies once again for coming on late. And yeah, and see how far that goes. Remember, if you have any further question during the course of your implementation, you can always ping me on Slack, and I'll be there to respond to you always.
Okay, sir.
All right. Miss Amen, can you hear us? Hello, Miss Amen. All right, dear, this is no problem. No problem. Do have a lovely day ahead.